Okay, so for an example of this trigonometric interpolation using the discrete Fourier transform, consider the following data. Okay, so if we consider the vector x and try to interpolate over the interval from 0 to 1 with equally spaced nodes, t, time, gets discretized accordingly into 8 equally spaced nodes between 0 and 1. And if we take the discrete Fourier transform of x, which of course MATLAB can do rather quickly using a function called FFT, we get that y is equal to, first entry is real according to lemma 10.4, it's minus 5.5. Second entry minus 1 plus 3.6i, 1.6 minus 1.2i minus 0.5 plus, sorry, not plus, minus, let me redo that 5 as well, minus 0.5 plus 0.3i. The fourth entry is actually real as well, so basically the n divided by 2 entry is always real. And now if we use lemma 4, we actually, starting with the entry before the n over 2 entry, that would be the minus 0.5 plus 0.3i, this entry here is the conjugate of that, so we have minus 0.5 minus 0.3i. And then if we go one above that, we take the conjugate, we have 1.6 plus 1.2i, and this is actually the result of the discrete Fourier transform of x. And then the one above that, if we conjugate, we have minus 1 minus 3.6i. Okay. So now you can see what the a's are and the b's are, and we plug this in to p sub n of t. And that's the p sub n of t that is in corollary 10.8. So p sub n of t is equal to a sub 0 over square root of n minus 5.5 over the square root of 8 and then minus 1.1 over the square root of 2 cosine of 2 pi t. Remember, our formula was 2k pi. In our summation, the formula for the cosine is 2k pi t minus c over d minus c. In this case, if k is 1, c is 0, and d is 1, we get this nice simple formula, 2 pi t. And then we have a minus 3.6 over the square root of 2 sine of 2 pi t. And then plus so, and just to note that in p sub n of t, in front of the sine term, there is a minus sign in front of b sub k. So our b sub k was 3.6, and we have the minus sign. The next term is plus 1.6, that's our a sub 2, 1.6 over the square root of 2, cosine of 4 pi t. Okay, k is 2 now. And then we have plus 1.2 over the square root of 2. B sub 2 is minus 1.2. Sine of 4 pi t. And then minus 0.5 cosine 6 pi t. And then our b sub 3 is minus 0.3, so we have a plus 0.3 divided by the square root of 2 sine of 6 pi t. This concludes the terms that are in the sum, and then we have plus a sub n over 2. Our a sub n over 2 is real, it's the minus 0.8. And so we take that term, divide by the square root of n, so we have a minus 0.8 divided by the square root of 8. And now this is times cosine of 8 pi t. So this is our trigonometric interpolant for that data. And if you look at figure 10.6, it shows this a plot of this trigonometric interpolant along with the points, the 8 data points.